Hi there, ladies and gentlemen. This is Mr. Workman, and I'm going to show you how to go through converting between the number of moles of a substance and its mass, as well as the reverse. If you have the amount of a mass of a substance, figuring out how many moles that would be. What's also implied in figuring out how to do this is figuring out the molar mass of compounds, and that will be demonstrated in some of the problems here. And what I have here is essentially an answer key to this document, and you may have a document already done like this, or maybe you have a similar document. This is just a document wherein you convert between moles and mass. What we're starting with here is just a real quick example. So if you were given 2.5 moles of copper and you were asked how many grams that was, this is how you do it. And if you're doing the domino method, of course, what you do is you line up your moles with your moles and your grams, and what's not actually shown in this document is another domino, which would be your gram domino. You match your grams with your grams. And then what you do is you rotate your domino counterclockwise. And what you get from rotating that domino is grams over moles. The other way to think about this is you take the unit you're given and you multiply by the unit you want divided by the unit you're given. And the math of this works out because we know that 1 mole of copper is equal to 63.55 grams. So essentially, because this quantity, 63.55 grams of copper, is equivalent to 1 mole of copper, we're essentially multiplying by 1. And so the quantity of the substance here isn't changed by the math. But what we do is cancel the units. Because moles is in the numerator of this fraction, and it is in the denominator of this fraction, the mole unit cancels, and what we end up with is the unit that is not canceled, which of course is grams, and that travels to the answer. The math here is pretty simple. It's just 2.5 times 63.55, and then the answer, of course, is 158.88 grams of copper. Now, when you're doing these types of problems, you need to understand that your chemistry teachers, not just me, are going to probably expect that not only do you show the full answer, the number with the proper unit and the substance, but also the work that you did to get to the answer. So let's look at this first problem. And in some circumstances, as is the case with this problem number 1, what you're going to do is be given the words of a particular compound, and what you'll still need to be able to do is translate words like this, iron, Roman numeral 2, nitrite, to the particular formula. Now, you know that iron 2 is Fe with a 2 plus charge, and each nitrate is a minus 1, and that's NO2, and so you need 2 nitrites for every 1 iron, and so the formula is Fe in parentheses NO2, and then another 2. And of course, what you should also be able to do is figure out the molar mass of compounds like this once you know the formulas. And you need to be able to count the number of atoms in these formulas. As you can see from this formula, there's 1 iron. There would be 2 nitrogens because this 2 applies to that nitrogen as well as this oxygen here. And because there's 2 oxygens within the parentheses and we multiply this, 2 times 2 is 4. There's 4 oxygens, 2 nitrogens, and 1 iron in this complete compound. What you do, of course, to figure out the molar mass is add up the molar masses of all the atoms in the compound. The molar mass of iron is 55.85, the molar mass of nitrogen is 14.01, and this, of course, is all in grams per mole. And the molar mass of oxygen, some periodic tables will say 15.9994, but I've rounded that to 16.0 for this particular problem. What you do is you take these molar masses and multiply by the number of atoms that are in the formula. And so you extend that multiplication out here, and then what you need to do is add all this up. You add these numbers. This should be 28.02, 55.85, that's 64. Add all that up, and your answer, of course, is expressed in grams per mole, 147.87 grams per mole for iron 2 nitrate. Now in this question, what we're doing is we're going from moles to grams, and so you start with what you're given, 3.45 moles of iron nitrite. You can put that over 1 because that doesn't change the quantity of what this is, and then you multiply it out by your molar mass domino if you think about it in those terms. Much like 1 mole of copper is 63.55 grams, 1 mole of iron nitrite was already figured up here. This effectively becomes a molar mass domino. And now What we need to do, though, is line it up so that moles are next to moles, and you rotate it so that moles are on the bottom, because I'm trying to cancel away from moles and get to grams. The math of this is pretty simple. It's 3.45 multiplied by 147.87. Moles cancel. The unit that isn't canceled, of course, is grams, and that travels to the answer. Problem number 3 is the reverse of problem number 2. Here you're given 200 grams of iron and you're trying to get to moles. And you're going to multiply by the same fraction, well, rather the inverse of the fraction. You multiply by 1 over 147.87. Because again, you're trying to cancel grams, so grams are on the bottom here, you're trying to get to moles. And the final answer here is figured out by taking this number, 200 grams, and dividing by 147.87. Dividing by 147.87 is the same thing as multiplying by 1 over 147.87. The next problem deals with a different substance, so what you need to do is figure out a new molar mass. The molar mass of nitrogen, of course, would be 2 times the molar mass of nitrogen atoms. So this, of course, comes from the periodic table that's at the bottom of the box for nitrogen on the periodic table. You multiply that by 2 and we get 28.02 grams per mole for N2. N2 is, of course, 2 nitrogen atoms. That's a nitrogen molecule. When we're trying to convert between moles and mass, what we're doing is we're going to multiply the number of moles we're given by the molar mass over mole. So what I do is multiply 6.3 by 28.02. And since moles are on the bottom down here, we're essentially dividing by this, but dividing by 1 doesn't really change the number. So 6.3 moles multiplied by 28.02 grams divided by 1 mole is all of the math involved here. Moles cancel, we end up with grams in the answer. The next problem is similar to problem 3 because we're starting with grams rather than moles. But of course this is a new substance. This is sodium chloride, and the sodium chloride, of course, is a sodium atom and a chloride atom, well actually a sodium ion and a chloride ion. And you add up the molar masses of the elements in that compound, and the molar mass of sodium chloride is 58.44 grams per mole. And I'm going to need that in my conversion here. I'm converting away from grams and going to moles, so what I'm going to do is multiply by the mass I've been given, 84.6 grams, by 1 mole over 58.44 grams, and that gives us 1.45 moles of NaCl. Problem 6 here, what I did with problem 6 is I figured out the molar mass first of this compound. 1 copper, 1 iron, 2 sulfurs, and what I'm doing is I'm multiplying those numbers, the extension of those numbers, and now I'm going to add all that together and I get 183.54 grams per mole. If I want to figure out how many grams is in 3.95 moles, I need to do the conversion now. 3.95 moles of that compound multiplied by 183.54 grams per mole gives us grams. So the math is really just this number multiplied by that number. The moles cancel and I get grams in my answer. The next problem is similar, although it's the reverse because I've been given grams and I'm trying to figure out moles. This KMnO4 material has 1 potassium, 1 magnesium, oh no, that's manganese, and then 4 oxygens. What you do is multiply by the number of atoms that are in that formula and multiply those numbers by the atomic masses of those elements. Add all that up. Of course, this is all added. So these numbers all added together give us this number. And so KMnO4 is 158.04 grams per mole. If I'm starting with 100 grams of that material and I want to figure out how many moles that is, I'm going to multiply by 1 mole per 158.04 grams. Grams cancel grams, and I get to moles in my answer. And of course, your answer should be complete. You should have your number, your unit, as well as the substance in your answer. So that's just a quick reference on how to convert between mass and moles, or moles and mass of a variety of compounds. Thanks, everyone.